Okay, finally think I'm going. Yeah, I think all of them are kind of on the same shape here. So what's going on is I've got my metric templates. All of these are essentially kind of the same shape and barring this keyway up top. And I can't remember, do I even say you don't have to draw the keyway? I say don't draw the keyway. Yeah. So I'm kind of focusing on just the square ones, yeah, or the rectangular shapes, and each one, and then I've just made a grid here, and that's just to break it up. That will be common on some drawings that you may have a grid that breaks up views. I mean, this is a little bit of a tight grid, and realistically, if I really had to dimension these, they wouldn't all fit with dimensions, fully dimensioned. I'd have to put these on a couple sheets. But and we don't even have to dimension anything. It's just that some of these dimensions help us draw. And then I made a 30 by 60 block 30 by 60. And essentially and I've talked through this, what these are is a front view and a top view, front view, top view. So they're the same. This is like a multi-view projection here. Only two views needed. The reason why we only need two views is the other view it might not give us any new data. So it's not needed to have a three view. So these are kind of technically the first little multi-view drawings we do where we have like a top and a front view is what I'm looking at of a block. So this thing is really just a block that's it's just 30 by 60 by 30. 30, yep. And so let me talk through that. So what I'm gonna do is just do an array of that little block pattern. So I might draw a top and I might draw one single one and copy it, and then I might array those two to make this grid. That's going to be like a 1, 2, 3, 4, 5, 6 by 2. Essentially, it would be my array pattern, like a 6 columns and 2 rows. So I'm kind of heading in that direction when I jump over here. I'll keep this up on my other screen that I can see. But and maybe I'll just start this with an actual visible line and a rectangle to draw the first one. These are in millimeters. So yeah, I think I'll just draw it here. Maybe I'll array it up and to the right. But so these are 60 millimeter this way by 30 millimeters. 60 by 30 is the front view of this. I'm going to copy this. I'm just going to move it up here. No specific spacing. I don't know on my actual drawing how far apart I've put this. It might kind of matter, but I think I have some leeway here. What I mean is when I look at this, and I look at if this truly did fit on an A4, it probably does. I had a lot more room to work with, kind of top of border to bottom of border area. So I could have spaced these out even wider, maybe in between these, but I don't know what that measurement is. I don't think I put it on there. It would kind of matter if I don't know how much room I work with. So sometimes when I do this, and what I'll do is to kind of help myself know if I've got enough space here. I might draw that paper in my model space temporarily here. So I have that paper layer that sometimes comes in handy when I do this kind of stuff. I just want to know the size of an A4 size border area. This is the room I have to work with if I'm doing a single viewport on these objects, which I'm going to. So I do a little pre-plan here, and I'm going to measure like maybe I'm going to measure if I get out of that drawing. There we go. I'm going to measure how much space I have this way. It's 171, essentially almost 172 millimeters I have that way. So like 172, I'll call it by from here to here is all I have to draw with 272, 172 by 272 would kind of be my border area. So sometimes I use that to my advantage here on my paper layer, and I'll draw like a uh, a representation of what that might look like. I think we said it's 272 this way and 172 that way. I just placed that anywhere. I just wanted to get a look at like what my spacing looks like. I'm gonna move this up a little bit closer to the bottom and maybe over here a little bit, something like this. Yeah, go ahead. Right.
Feel that we're having enough room where will the rectangle be twice as big?
In this. That's true. So I have like t twice as, hey, that's a good point, Riley. Like I'm gonna look at it a one to one. It's gonna end up fitting in this size, but I'm gonna be able to fit twice as many in here, right? So yeah, you're right. I could draw this up twice as big. Good call. Good call. I like that. What we're saying is that's gonna end up these are gonna end up being half scale. So I actually have twice as much room to, if you notice it looked like I would never be able to fit that on that rectangle. Uh, because technically this is going to be twice as big. So I could draw this at what's 272 and 172 twice. 272 times 2. That's how many millimeters I have, 272 widthwise. But I can be twice as big as that because I'm going to be at half scale. So 544 and then I think I have 172 twice. 344, 544 by 344, I think is what I'm going to make this rectangle. I would have recognized that once my array like fell off the sheet. I've been like, wait, I should have room. So now I'm going to move this up because yeah, we don't do this a lot. So I'd say this is kind of a one-off. No, not necessarily. We do that a little bit, but I wouldn't say I have to plan it out exactly like this every time. And so I can't say, but essentially what Riley corrected me on is that I'm drawing it one to one, correct? But I know on when I get to this paper, it's going to be 2 to 1. You can already see that's quite large. These have to, on my paper, if I click into the zoo port, it's really going to be if I unlock this and put it on a 1/2 scale is what we want to finish this at. This is how much room I actually have to work with. See, that's why my sheet size kind of fits in my border area here. Let me resize my viewports and make this a little clearer. But I'm going to lock this down momentarily. I can get rid of my calculator for a minute. I'm going to jump out here and maybe I'll just draw my viewport out to my border area here, or even beyond just a little bit, so I can see how that gray box I just drew. This becomes a teaching moment now, is what I've realized. I'm going to click in here, just turn off the grid for a minute so I can just see let me unlock this for a minute. Let me center this so you can see, but here is my gray. Notice how my gray box at a half scale is going to fit what the borderland area is. And that's just because I'm already kind of pre-planning that technically my objects are going to come in at half scale. So if I'm drawing a paper boundary in model space, I kind of have to think about that. But I would say if that's confusing the crap out of you, that's okay. But this is what's happening. It's kind of a nice visual representation of how scaling works from one to the other. Now I know that all my blocks will fit because I'm at a half scale. So I've doubled the size of the paper in model space to kind of replicate that. I just feel like that might be a little confusing. And I'll lock this down momentarily here. And then I'm just going to go back. I don't always center that up in my paper until I'm ready to like done, but that is a good observation that made me think a little bit. So there's what the room I have to work with. There's the space I have in between two objects. Really, I can go all the way up there. So I feel like I could space these out a little more, but really, nah, I think that's okay. I think what I can space out a little bit more is the distance between the two, like the two rows. I could space those out a little bit, maybe more than I have here if I was looking to correct it a little bit. Like I feel like maybe all these are the same space, and maybe I would have liked to have the row spacing just a little bit wider. That's kind of why there's a few things that I feel like I could correct on this to make it a little bit clearer, use up some of my drawing space a little bit more efficiently. So with that even in mind, I feel like I can just take a guess here, and I'm going to move this one just a little further away. Critical to move, if you're moving this, I want to keep this orthographically aligned, which means it needs to be like straight and parallel this way. And if I'm doing any right side views, they need to be straight and parallel this way. So that's orthographic alignment, right? So I'm just giving myself a little more room. I still got plenty of room. That'll be great. I'll probably actually on the paper, I'll probably add more space here than I really have, which I can move those if I select them both now. If I can select that, there we go. Maybe on my paper it'll actually be something up here like this. And then I'm just going to array this. I'm going to array this as a rectangular array. I'm going to select both of these objects that I want to array, and they're already kind of showing up because now I got the ribbon menu as a as an array control. I'm only doing 2 rows, and I'm going to do, is it 6 columns I needed? That does fit, so that's sweet, huh? 2 rows, 6 columns, and then I could increase in between a little bit. Maybe I'll just go for a nice round measurement of 150 millimeter. I could even go a little more as I watch that shift. I'm like, oh, maybe 170 millimeter. That's kind of what I wanted, was just maybe a little separation between them. I'd almost feel like that's a little too much. But there is no right or wrong here to me. Like I would never criticize yours for whatever you've laid out your grid pattern, as long as they fit as at a 1 to 2, that'll be fine. So this is what I'm going to go with. Just a little more separation between rows. It seemed like the default was 90 when I put in 6, so that worked. So I didn't even adjust this. I don't have much more room to work with than that. So I think that was defaulted to 90 for whatever reason. That's good. So I'll say I'll close that array, and there's my objects that I have to work with now. So I'm just gonna work these kind of from I don't think any of them are harder or easier than the rest. Maybe they're harder and easier to see unless you zoom in here a little bit. But I think I'll just start at the top left and work myself away, starting with the counter bore. Then we got a chamfer, countersink, counter drill, drill. I get some hidden line work. Some of this is just because it's the first some hidden line work that we use. But I will start this with the top view, and I'll do these 2 diameters on the geometric center. So I'm going to do a 20 diameter, 20 millimeter diameter, and a 10 millimeter. And so let's do that. 2 circles on the upper. Yeah. This one here. These are going to be visible. These are looking top down at a block that has kind of a counter bore. Uh, and that would be a machine. Well, a machinist would have had to put a counter bore into something like this. We can 3D print stuff with a counter bore in it. And but I mean, I can use center diameter if I want, but I'm just using the geometric snapping to the geometric center. That's that object snap down here, geometric center. Should look like just a star, but I needed a 20 diameter one, and then I needed a 10 like that. It's hard to tell what's going on just a top view, but what we do, how orthographic projection works, and will continue to work for quite a few weeks now in our drawings, is what we do. We don't have to draw these as 2 independent drawings. Like I use one drawing and the details this is the principle of this is the principle of orthographic projection. I can just use the details I've done in one view to just project those to the other view, right? And so this is kind of my systematic approach to that. I don't even have to like necessarily draw in anything down here. I go to my construction layer and I use projectors or projection lines. I just pick a line and I will project down how it would look in the front view, which in the front view, circles, when you turn that block and look at it in a front view, the circles will look like rectangles. That makes sense. We call that the rectangular view of the circle. And so how I actually get that is I come out here to the outermost tangent edge, which quadrants are a great snap to have on for this. And I want to project this down to my block. Keep a nice parallel 90. You can use ortho mode if you want to. I just make sure that I have my this one on here that I get, sorry, this one right here. I make sure that my snap tracking is on. And let's do this down to the next one. So I'm going to pull the outermost sides of that circle down, and then I'm going to pull the innermost quadrants down here like this. And technically, you could draw some of these like fully down, and I'm just kind of being strategic here, knowing what I'm doing, but I'm pulling these inner ones down further. That's the inner bore of this counter bore. So counter bore, if it was cut out of plate or whatever, they may put an initial hole in the plate where it goes. Sometimes machinists don't even like that. They would just like to maybe be delivered this square block cut. And then they would maybe go in and actually do the counter boring. They would find the geometric center of their part, and they would have, essentially a machine, which is like a drill or a drill press, but they're a mill is what you call it in a machining world. And it will like bore that hole with the right tooling in to the right size. And then we'll come in and put a whole different tool in to actually do this like bigger diameter cut. And that's going to fit a bolt, is what it is. The reason why we use a counterbore, the reason why I'm actually wanting to draw these in class is just to discuss like and I'll pass this around, and I'll pass around the one that this is what would need a counterbore. So this fastener is going to go into a plate and maybe hook two things together. We don't know what's going on. I'll pass this around. Counterbore is for that. Those type of they call that like a hex head, or they call that a socket head machine screw. But a lot of times that type of fastener is being passed around. We like to sink them into the material. The head of that we don't like. It's really tall head. They're really strong. They can hold a lot of torque. They're a really strong bolt, and the head has a lot of power in it essentially. So, but they're really large. Like that head is really large, where the tooling can be to remove it, engagement. So that we don't always like that to be sticking out above the material, and can be there are applications where it's okay, whatever move. And it can be that but it's just going to be this big head sticking above the surface. So what we do, and a lot of times when we use that type of fastener, we sink the head into the material, and we would have a machinist do a counter bore for us. And then my head would finish flush to the material surface. And you see this kind of configuration all the time. But what I've got now is I've just got what the diameter, the rectangular view of that round circle. Like I have a place that I can snap to and draw that in. And then I have it that it's like 12 millimeters deep. That head in this particular case, I don't know if it's not going to match that one that I'm passing around, but it's like 12 millimeters deep. And so what I'm going to do is I'm going to move over to my hidden line. But in this view, because the part has been bored in the middle, in the front view, I can't see it. It would be like I need X-ray vision to see what's going on if I actually turn that block 90 degrees from the top view and looked at it as a front view. I wouldn't be able to see it. So I have to show it in this view as hidden line work, and so that it gives us kind of X-ray vision in our drawings. So I move over to my hidden layer, which we've already programmed to be like this uh, equal pattern dashes, and it's green on a layer of its own. So these are hidden lines, and so I'm gonna choose my hidden line layer and align. And what I do is this thing looks like this. It comes down 12 millimeter, and then it comes across until it meets this other side. So I can just kind of use that snap tracking to help me align there. And then it's going to go back up and meet there. And so those projection lines just let me easily show that's kind of what that rectangular view. If you turn that bolt in your hand on the side, if you look at it at the top, that's kind of what we're looking at. And if you turn it at the side, you can see that it kind of looks like a rectangular side view. And then what it does is this thing now goes through to accept those threads, and it would be like going through this block and maybe attaching to something else. So this is, we have unfinished stuff going on here. We don't really know what I'm attaching to, but this would come down like this. So I have my hidden line on still, and this is kind of the inner bore that goes down. And then I would say enter. And the nature of hidden lines they are actually visible features, right? Like that is that drilled hole, two different diameters, one all the way through, one just only 12 millimeters deep. Those they don't get in the habit of trying to extend those like a center line. These are actual. If this was in my view, if I could actually, if I would have actually take a cutting plane line view right here and cut through this would be visible line work. So it has to terminate where the other visible lines are. So generally your hidden lines are going to be like bounded by visible lines almost all the time. So these don't extend past. They are visible lines, but I can't see them, so they're hidden in my view. So I'll just drive that home. And then all we would need to do to finish this view is put some center lines on it. So I'll jump over to my center line layer, and I'll jump over to the center mark. This one's a handy one for this one. How far in millimeter lands are the center lines supposed to extend? 6 millimeter extensions. That's the equivalent, essentially, roughly the equivalent of quarter-inch past those edges like that. So I feel like on my view, I don't have it right, actually. And where I have a little bit of breaking away, I'll just leave that like that. I feel like 6 millimeter works good. Maybe it looks a little bit excessive, but these are small parts, and that's good. I'll leave that. And then I want the center line, and I love to use on the same annotate tab where I get my center mark. This is a great application for the center line. What this wants is you select two lines, which are features, and it will apply a center line perfectly between those two lines that you choose. So in this case, let me show you here, but it does bind it by how long those lines are. So like, I'm on my center layer still. I'll pick this command, center line. And if I come down here and it's like select first line, I want a center line that runs down through here. So if I pick this one and I pick this one, it will end up being a center line like that. It only is using the extensions past the actual length of the line. And because I chose this, that's why, it's default extensions are just beyond that point there, which is not sufficient for what I need. I need to go all the way through the block to the top here. I want to pull this up to here to show that there's axial alignment between the lower bore and the upper kind of bore. Like we're showing that there's like a center line alignment, concentric or axial alignment. And so so that would be, I mean, so I end up having to like pull this up, and what I'll probably do is just pull the square grip up to here, and that square grip is already locked in there. And then I can actually adjust the extension on the properties panel here to say, oh, I need these to extend 6 and 6. And then I've got to my center line extension. So I use this one a lot. I love these two. I mean, in the mechanical world, I use the heck out of these. So that is the counter bore. We could put a title on it. I don't think I think I say you don't have to title them, but so we can just keep them simple, use the KISS method. But if you did title them, that's cool. I mean, that's great because it would just be a matter of probably going through the sheet, going into the viewports, and then adding a multi-line text right here, and then naming them. And then I could name one. I could just do one and then copy it over to all of them. So it wouldn't be a huge deal. I would maybe do it at the end if I'm going to do it and I have time, which I likely will not have time today. At least I don't think anyway, but that's good. And then, so let's do the next one, which is a chamfer. So chamfer we've already kind of used. But what I'll do is I'll do the chamfer right here in the front view, and then I'll project it up to the top view, and it'll help me draw in what the chamfer would look like in a top view. So in the front view, we'll use our chamfer command. It's a 2x2 mm chamfer. So I'm going to go over here to I don't even need to be necessarily. I'm gonna get ready to be on probably my construction layer here, and I'm going to use chamfer though. That's on the modify command or palette underneath fillet or whatever you use last. There's chamfer. These are the two kind of annoying ones a little bit, but once you get using them a lot, it becomes a little bit second nature. But you got to put in a distance. It just doesn't, every time you load CAD, the default's going to be 0 for chamfer and 0 for fillet. Unfortunately, I haven't made enough calls to Autodesk to get them to just preload some number other than 0. But so I picked distance first. So I usually remember to have to type D for distance or select it. And then I need it to be 2 mm on both. It's an equal leg chamfer, so 2x2. And then I'm going to choose this. Doesn't matter which one. With an equal leg chamfer, it won't matter which one I choose first. This one. Oh, let's see here. What am I doing? I don't know. I should be able to choose my first line. What's my chamfer? A distance is 2 and 2 and this and this. Oh, I know why. Is it because we're in an array and it won't let me modify this array? Probably. I probably need to explode my array. If you found yourself like not being able to control these, it's because array is controlling them. And I just used the array strategically. Now I'm going to explode this array. And now I should be able to chamfer this. I've got the preloaded size as 2x2. That's exactly what it was. So it's going to control any modifications when you're locked into an array, unless you're going to go in and let you edit the array. But I actually just wanted that array for that. This is a good reason to explode an array in this case. So, and then I'm going to just project these up. So how it should show up in the top view is I should see this as a visible line in the top view, because that's kind of like material that's been notched away and it's kind of like falling down and away. When I look at the top view, that little chamfer is kind of like falling down and away. So it looks like this, right? It's just a line. I mean, it's really simple to draw, yes, but the concept is this is falling down and away from me from this point down to there. That's falling away from me. So what we call that, you've learned about in chapter 8, that is called foreshortened. That means that when I look down on top of this, when my eyes are perpendicular to this plane here, when that bevel falls down and away from me, it is foreshortened, meaning that if I were to snap a dimension here, or if I were even to measure this, um, it is not it is not the dimension of how long this is, right? It's Pythagorean theorem a little bit to me, or it was what I think of, or I just think of like the hypotenuse of triangles. And I think about that this is, if I needed to actually measure how long, I mean, I know it's 2 by 2 this way, and that measurement is true here. It's two across one leg of this little triangle right here. But the hypotenuse of this or this is actually longer than 2 millimeter. So if I needed to know like how long that is, I could not pull up this dimension here and or this view and actually measure this. This would measure 2, which is not how long this measures. So what we have here is two views. One shows a foreshortened view of that particular surface. The length of that surface is foreshortened in the top view, but in the front view, this is true length here. So I could pick this dimension as being that's how long that is. So we call this like true length and we call this foreshortened length. And that's why we need multiple views of objects as we draw all the rest of the semester is some views, some things that we need to dimension are foreshortened, and I need and another view where that is actually the true view to be able to pull dimensions. And so we'll use that concept a lot. And so I like to explain that here. But that's really all the construction work I would need to do on that one. That one is the chamfer, right? Countersink's next. I'm going to start it the same way that I did the other one. I'm going to use the geometric center. I have that it's what? It's 12, it's 8 millimeter on the inner and 12 millimeter diameter on the, so I've got the diameter out here. 12 is the larger diameter for this countersink. And I'm going to review another one is 8, but I'm going to say 4 because so that's what the countersink looks like. And then let's draw this down with my construction line work, project these down from the quadrants down to the block. I'm only going to probably draw this one to this right there. Yeah. And then I'm going to repeat that here. I think this one's kind of tricky in that, and then I'm gonna draw these ones all the way through because they actually are the through bore that goes through. So that's the only reason why I'm bringing this all the way down. I know I get some overlapping lines here, but I'm going to turn off my construction layer and it's not going to print anyway. So I'm going to draw these from the quadrants down through the block because that's the through hole all the way through. Enter. This one we just have a little bit different going on here. It's like it's and I'll pass around this one. This is called a flathead machine screw, and we sink them in the same way. We would have a machinist do this, or sometimes we can do this from our home drill press. Depends on how big, and these come in all shapes and sizes. But here's a flathead machine screw. This is a hex head flathead machine screw. It has these real common fastener. Maybe it has less torque load available on the head to the surface that it's mating than that shoulder bolt does with the big counterbore. This one is maybe less torque available. It all depends. Sometimes torque and how tight I can tighten things are based on the size. So large ones I can pass it around. That is a large bolt that they come around. That is sufficient to hold like substantial torque for sure. That head surface. But what it is the bevel of this head that's coming around, this flathead machine screw, is what actually mates against the block. And but we like to sink these generally. Like these ones always, like a flathead machine screw, always with these kind of tapers or these angled heads. They usually, I've never seen them not get sunk into the material. So there's a different type of tooling that cuts that into like what we're drawing, and we are drawing what will accept these bolts, not what There's more to these drawings than this, but this initial drawings that we are drawing are just where that bolt might go into. Of course, when you're drawing stuff like this, that's going to accept bolts. There's tolerances involved. There's threads that have to be cut in some instances, but this is a common machine screw, flathead machine screw. And what I need to do is do the maybe some hidden line work and draw these draw these down. What it is this is what's confusing about this one, and I won't even probably grade this right or wrong, but it does say it wants to be 82 degrees. That's a really common like, and that's called an included angle. So really, it's 82 degrees on both of these. If I from one side to the other side of how that angled mitered head fits in there, and they have different degrees. Like these flathead machine screws come in a few different degrees. 82 is a common one, but there's also steeper, and and anyway, there's a few different to choose from. And it does take a special kind of cutter to cut that out. Almost adding like a bevel, or almost it almost looks like a chamfer in the front view. But it would be kind of like a radial chamfer or a round chamfer. And so it's a different tool that cuts that than would cut the other one, the counterbore. So let's just see if I'm on hidden line view, essentially what it means is it's coming down here, maybe to the center area, and the degrees are going to be tricky to figure out probably. I don't know. Let's see. I might put a center line in here so I have something to maybe snap to. I want that miter to just come down and hit the center line and then come back up there. And then so let's see. What will I do? I don't know. Maybe I'll put a center line in there real quick. I can actually just use my center line from here to here temporarily. It's a little excessive. I'll pull it down here. Back on my home view, maybe. Why I think this is kind of confusing is I may not be able to lock in on an exact dimension. Like half of 82 is like 41 degrees, but I have to kind of think of like, well, it's 41 degrees kind of from here over to there. Like this will be 41 degrees. And so what will that be from here? That, well, I don't know. Let's see. Um, I probably want to draw it by degree here. And what would I say? That is there. Like this is 90. It's like thinking backwards to me is a little bit. So I probably will fumble this a little bit. And maybe I'll pick a dimension and then hmm, it wouldn't be 139, would it? Maybe. Actually, ended up I put in 139. Let's just see this. And then I'm going to come back here and I'm going to draw this one down. Then I might check this dimension. What do I have as an angle dimension between this and this? 98. So I actually didn't put in the right one. I'm actually how many degrees off? I'm like, I need to be 82 and I'm 98. Sorry. 16 degrees divided by 2. I should have gone like 8 degrees difference. So I'm actually too much. I need to go. I'm gonna redraw this at 139. I think I used 139, but it was 8 degrees off. So I think I need to add, bear with me here. This is how I would do this, is I would say I used 139 at first, I think. Tab over. But I needed to be less than that by 8 degrees, kind of. So I say tab over and say, I think I need to go this way. Yeah. 139 plus 8. I'll tell you, it's 147 is what I'm thinking. 147. And tab that over. I think that's the wrong way. I want to go the other way. 139 plus 8. 131, I think is what I want. Tab 130. Tab. Is this more correct? Let's see. If I draw that one down. I'm going to measure this. 82 degrees. I got it. So it just took me some figuring. This is this is because I feel like and I feel like if you're new to CAD, maybe the putting in a degree might be kind of tricky because you have to think of degrees as which side of and in my video I even discuss it. This reminds me of Cheshire Cat, right? Which way do I go in my degrees? I don't know. It depends on where you came from or where you want to go, right? And so you have to know like where your reference point is, where you're trying to end up. I did try it a couple different times. I did one. I kind of took my best guess. Is it 139? And then when I put in a 139 degree, that was from here to here. And I did that twice where they come together on the middle. Then I checked that and I was like, oh, this isn't, this degree it was 98. I was off by uh 98 minus 82, 16. I was off by 16 degrees. It's an included angle, so I only needed to make like half of that adjustment. Anyway, I don't need to go into this too detail, but I can repeat what I did here and I will trim this. So I'll show you what I did. These ones are incorrect, but I used them as a reference briefly. I didn't just delete them when they were wrong. I used them as kind of like, well, that was wrong, but I need to go this way. I need to make it tighter pattern in here, this 82 degrees included. So essentially the measurement that I use as I snapped from here and I went in here and I said, I'm going to tab over to the degrees. It was 131 degrees from there. And then I pulled it down to that center line that I had. I kind of needed I needed a place to intersect that at center. So that's why I snapped my center line first. And when I hit 131, and I pulled it to center, then I knew I only had to go to the other side and pull down from there to center. Don't get hung up on how the heck that is. And if it's not a true 82, I'm okay with it because it's in the event when we really start having a part that has these countersinks cut in it, I will need to be accurate. But here it's just kind of an exposure to what's going on here. And if I look at my here, the last thing I need to know is from those points where they hit that side, I'm gonna drag this down. The only part that's going to be mitered and beveled like that is just where it accepts that head of that fastener. So essentially my hidden lines will now pick up from this point down to through the block here and to the end of the block like that. So I mean, if you've already done this, you should go look at your drawing and see if you did hit 82 degrees or not. And then I actually just trim some of this and see if you could correct it if you have time, and if you didn't quite draw it correct. Um, is there anything else in there? That's it. I did you this one. It's a debate. It will have them. This is debatable whether this would come across like this or not, but I think I'm going to put it like that. It might show it like that in your book. So we did that way on the counterbore as well. I think that is the correct way to show that. So I'm going to throw that in there too. This hidden line across right here. And then I just need to make sure these extend correct, which I think they need to be 6 like that. And I need a center mark up above on my center layer. And I could just use this to match properties too, right? I could match properties with this one to this one, get those extensions relatively fast. And then we've done those 3. Oh man, we got a lot to do, but we could take a break and come back to this if we want to, or I can just keep going, but I'll just keep going because I was a little slow to get started. But if you need to take a break, you can. I think some of these will be a little quicker. I've got drill, which is just a 16 through. That's just a straight through hole drill. Some machines can be accurate enough to cut holes like lasers that we cut with water jets. Water jet uses like a carbide sand mixture and really high pressures to blast through, almost like sand blast its way through materials. And it can do all kinds of materials, marbles, plastics, steels, really thick stuff. Water jets are amazing. They're really slow cutting. Lasers are very fast and maybe a little more well, no, actually water jets are probably the most accurate. But generally, if like sometimes through holes cut by machines are sufficient for production, and other times it's not. Other times it has to be machine true with real accurate tooling. So, anyway, This is just a drill through hole. So 16 diameter circle and just straight through this whole block. No real special thing going on. No threading going on, just a through hole. So let's draw that one. Should be pretty quick. Which one did I miss one? Yeah, I did skip counter drill. Let's do it. Let's do counter drill now. Counter drill is definitely a different, a totally different. I can't say I ever did. We used a lot of like counter drill methods for our fasteners here, but let's do this. So it's kind of a combination of those two, huh? Like a flat, like a it would be like a flathead machine screw, or sorry, a socket head screw, shoulder screw. Sometimes they call them a shoulder bolt, that first one that I passed around. But it would also have almost some features of the countersink on the underside of the head there. So it's kind of got three different processes. The machine's probably set up with three different tools to cut this. Of course, mills can be set up with like a they have like a carousel of tools that you load into a machine. And so you can program what it needs to do and the order it needs to do it, and then it'll just like switch out the tooling automatically. Well, I mean that's a CNC type machine, but yeah. You can load a lot of different tooling. It's not like an individual has to change the tooling all the time. Machines, you can almost some machines have like a huge carousel of tooling that's available that it can switch to really fast. We really should walk down the machining stuff a little bit more, but let's do it. It's the next one. Yeah. It's 12 and 8 again, right? So I'm just gonna copy these over. How about I just copy this? I'm gonna copy this. It's the same size as this last one we just did. So I'm gonna copy all these three items from the center. Love it. Over to the geometric center. That's that step done. I could have even brought my lines over, but I'll draw my own construction lines here. Uh, this is going to be the overall head width there from this one coming down. Then I'm going to have the inner bore, and then I'm going to have to sit there and figure out how to get 102, 120 is the included angle on this other one. And then it's 7 millimeters deep on the first. So I'm going to go to my hidden layer. This will also be hidden line work. And essentially I can draw the first kind of rectangle in. It goes down here 7 millimeters across till it matches there and then back up. And then from there, we kind of have this 120-degree angle. I'll think about what I did here. I used 131 to get 82. To get 120, um, it's a difference of 38, maybe 19 degrees more, but wider, 19 degrees plus, maybe it's 150. That's my first guess. Let's just see if I'm right or not. I guess 150. Let me bring this down. I'm going to snap in a center line real quick, though. Is that what you guessed too? Then you're on the right track. Your math is working for you. But let's see if it's right. Like, let me do my center line here. I'll snap this one again and pull it down. While I'm here real quick, and before I forget, I might do those. I hear what you're saying. I think I agree with what you're saying. I'm going to tab over to 150. And then I'm going to, I accidentally hit enter, and so it drops. So I use that extend command a lot. If I exited that command too fast. I put in the degree that I wanted, and then I hit enter, and it put in that line length for me. I like that extend. It's better than me pulling grips sometimes if I'm trying to be accurate. And then this one should go from here to here and meet up, at least initially, so I can do a quick angle measurement. 120 I got. But that was me based off of what I had done over this other one. So I think the degree I used to pull from there was 150. I tabbed over, it was a 150-degree input here. But that's not it actually that little taper stops right here where the actual through bore actually goes. Then I'll trim out some here like that. And I'm gonna put one more line in, huh? I think in my view here, I kind of show that across line here. So that one is the counter drill, right? Counter drill and then drill. What size is the drill? I'm gonna hope that it's 8 by 12, but it's probably not. It's just 16. Of course it is. Slightly different, but let's do the drill over here. 16 diameter. Match properties. Sure, I'll take this one to this one. I'm gonna project down, use my construction, my projectors, my projection line. It's just gonna go down all the way through. Down and through. And then I'm gonna trace that over with the hidden line. And then I'm going to snap a center line on that. So I'm on my center line layer again now. I'm going to use those two. They'll be a little bit short, but that'll be close to where I can just input the extension there. 6 mm extension on that. I think we've done the hardest ones, but I don't know. Some of these might be. This is a big fillet radius of 12. A lot of different ways you could draw this one. I'll just do a way, but here is a 12-inch radius here, or sorry, 12 millimeter radius. Big old scoop out here. Um, I don't think I give any other measurements there, huh? Yeah, I think you could draw this a couple different ways. It's definitely is like comes in more than 12 because I've got like a straight section, then I've got the radius section, then I've got a straight section, but I'm not given any dimensions here. So I don't think I think it would not be a critical thing. And what it might look like is a 12-inch radius circle I could use, I think. Maybe I've placed this maybe I've placed this with a circle by radius. Yeah, go ahead, KC.
Top one with the line.
Yeah,
The up bottom, you don't go all the way over. You can leave the open line, use the chamfer tool, put the radius in there, it'll automatically make it for you.
so you're saying this is how you proceeded, KC. You're saying that you did, tell me again one more time. Draw a line here.
Bottom one, obviously, it's the exact same.
Yep,
So,
yep,
how you made all the boxes before, you get rid of the top line on that box.
this one.
Yeah.
Yep.
Then you only drew over. Here's the tool that-
Yeah, I would have to explode this to get rid of that line. Yeah, yeah. That's okay though.
Right, the top one, but the top one goes down.
Yeah.
The chamfer tool, all you have to do is click on that top line and then your right line.
Yeah, so
Chamfer tool and it'll automatically make it for you.
it'll put this in right here.
Yeah. Make this exactly how to put.
Oh yeah. Yeah, I think I like what you're think. I think I like what you're saying. I agree with that. Because I feel like there's just kind of some missing information here that would like because you're saying you put this line in,
Yeah.
got rid of this line, and then it will put in this chamf or this, yeah, or the fillet. Yeah. Yeah, yeah, yeah. No, that's good. I think that's good because I think there's a lot of leeway on how you would put this in where you're kind of minimal. I mean, there wasn't a lot of dimensions given, and so I think that's good because it would be we could all what I do agree we could all end up with kind of a different dimension here and have this actually work for us. Yeah, and because this rate, what I mean is the center point of this radius could even go up a little higher, could even go over more because I've got straight section to work with. So really, the center of this radius is not. I haven't dimensioned it, so it could go anywhere. You're right. I mean, like, there's a lot of ways you could put this in, as long as you have enough room to put in a 12-inch radius. There would be some ones that wouldn't work. If I chose too small of an area here, I won't be able to fit a 12-inch radius because this thing will look like if I just pick a circle and just draw a circle that is oh, just anywhere here for a minute and I'll move it, but it's going to be a diameter of sorry, of 24, right? This has a 12-inch radius. I'll just move this and like show what it looks like. Like this has got the radius that has to fit in here somewhere, right? And I'm betting what I did. Okay, now what I think I probably did now that I look at this is that I bet you I did a tangent radius. So let me show you. This is just me not having done it for a year. But I'm betting that I came over here and did like a tangent radius, tangent to here with a radius of 12. It actually puts that circle in there. And then I actually drew some line from quadrant to straight and quadrant to straight. And then I just trimmed all this out. You can just like drag lines across here to trim. That's probably how I put it in. How you did it though, Casey, would absolutely work. And I wouldn't be critical at all of how you did that, given that there's just not, it's not clear information. I probably will make an adjustment to this and just put in a dimension to help us help you know, like all I would have to really put in is like this dimension where that edge is, and that would be all it would take to help you place it. But yeah, that's good. I like how you did it. I like that. I like for you that those of you that worked ahead, however you got it is would be correct in my eyes because it would be because it's like you weren't given any super clear information. So I'm glad when you can figure stuff out that work. That's kind of how that would look though, like that. Yeah. hmm Just trim the rest. Yeah, you got yeah. And we have used that tangent radius on that a few different assignments we've done, but you wouldn't that maybe wouldn't be clear. So I like how Casey was like, I would do this, and that's totally that would totally work. So and I just think we would all end up with maybe a slightly different length of this line here or there. And I wouldn't judge. What's that? Sure. I never even measured anything other than just that tangent radius. Yeah, that's good. It's good. No, I like it. I like it. I mean, and then on the lower one, we've just got a round radius or what's called yeah, just a round. It's a round is a fillet. Fillet's the command name, but sometimes we call it a round in machining world or in mechanical world. We'll call it a fillet too, but fillet and round I think are used interchangeably in this mechanical drafting industry for the most part. So you could call this a fillet, you could call it a round. It's a 10 millimeter round, and so that's all for to do this. This is the next one. I'm working left to right on the second row. I would use round. I would use round, and I would need to input the distance of the round. It's kind of like it's a 10, so I had to choose radius. Round or fillet and chamfer both in knowing that their default is 0, so I have to definitely put in a radius. I put in 10, so now I can choose this line and this line, and the round goes in. It's debatable and you'll see this. We'll do this both ways, but there is some debate here on whether or not it should look like this. If I put a construction line into where it transitions from like this surface to where it transitioned around, sometimes you will see in some drawings, they will actually draw in that edge, but and in some things it doesn't look like this in the thing, and I'm not going to actually draw it like this, but I want to say that technically this would probably be like I would say there's some debate here on what's right or wrong. Like this does kind of show like where the transition happens to go round, but likely on a part that is like truly like been machined round from surface to round, there would be no edge there. It'd almost just be this. It would be this. It would be this. The surfaces would be so uniform that you couldn't really see a transition point necessarily on a truly good machine part, and so you'll just see on some of the work we do, sometimes this is in here like this, and sometimes it's not. And sometimes if students put this in on their work and they don't, I tend not to be too critical of it. In this case, it's been left off, and so this one's technically kind of done. because it just shows that, oh, that it's like an imperceivable point of where that transitions to round. Still, when I look at that block from the top down, I may not be able to tell that it's round there because it just looks like a rectangle block. But on the front view, I see that, oh, there's a round feature on that upper corner that's right up against my eyes in the top view. But hey, go ahead. You sell. Can I say that one more time? Oh yeah, this round one? Yeah, for sure. The fillet. Yeah, 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 for sure. Let me just go back a few steps here before I even have anything. And it's the annoying thing about the fillet command is that when you choose fillet, just like you choose chamfer, it I think the command prompt is wrong, right? It says select first object. So if my eyes are following my cursor with my dynamic input on, I just go to start clicking away and nothing happens. The problem is I have to remember that on the command line, I need to put in a radius. And so you can come down here and just select radius and put it in, which is 10 by giving the print says it's a 10 radius, 10 millimeter. Then I can select the first object and select the next object, the two lines. So if nothing's happening when you're clicking that, I'm guessing that you just haven't loaded a dimension. Now, once you have the program open and you're using it, it will remember the last one you used. So now Chamfer probably has a 2 millimeter one preloaded for me, and this round would now or fill it would have a 10 millimeter radius input. So it'll always remember the last command you did. It's just that when you open the program fresh every day, it's just like gone back to default 0. And so just remember, those are annoying a little bit. And then we have a spot face. Okay. This spot face, I feel like is misleading a little. Sometimes, well, not necessarily. Let's uh let's draw this and I'll talk about what it is. A spot face looks just kind of like a mini little counter bore, and essentially it kind of is. I'll do those two circles by their diameter. Sure, is the 8 or the 9 or no, it's 6. Sorry, 6 and 10 are the size of circles here. So I think I'm going to have a 10 and then I'm going to have a 6 if I redo that circle. I can go ahead and do their center line while I'm there. Yeah. I'm just using a match properties to get those 6 extensions. It's not that big of a time saver, but we'll project down a little bit of construction work here. The quadrants, I want to project them down, make them rectangle. That's the larger diameter ones. There's my 0, perpendicular, enter. Inside bore, I'll pull it down and through. Sorry, I didn't pull that one down and through. I should. I'll extend it. I love the extend command. Bam. Okay. Keeps things orthographically aligned. And then it's just 2 millimeters deep. So I will just put in this bore. I don't think I have a particular, I don't have a fastener that's like this. In fact, when I think of spot face, I'll tell you what I think of after I draw these in a little bit. So I have these other lines that will come down from here down to the bottom. So I'll finish the drawing first, just the hidden line from there down. Then we need a center line there as well. Just watch where your grips are on that. I'll set these real quick. Okay. I feel happy. That one's kind of done. But what a spot face is, I think of a spot face when I think of I don't know, a coupler on usually it's an alignment. Usually it's a machinist will put a spot face in to kind of help locate something kind of quickly, but it's and so the depth of it's usually quite shallow. And where I think of when I think of what a spot face would be needed, I don't know if I do I think of like a manifold, like a pipe manifold with couplers. These are all mechanical. Ah, there we go. Hey, this is just what I want to show. So a spot face might be used in a situation like this. The, and I'm at Home Depot. Heck yeah, we're all going to Home Depot. So what has been done here is this is like a pipe manifold, real common way to distribute fluids, a lot of stuff. Piping is, is the fluid conveyor, but and solids even. But what they've done is they've actually like done some machine work to the pipe itself here, and they've kind of like recessed it down. This looks a little different than I would normally, but this what they've done to that pipe is they've spot faced it. They've kind of been aggressive here. And then this is called a coupler. And so um, where they've spot faced, they've probably drilled the hole through into this pipe so that this pipe is distributing something, and then it's being like this is what a manifold is. Think of your yard sprinkler systems. You have a manifold in there to distribute to different zones. If you have a sprinkler system, if you're dragging the hoses, I'm sorry. And but I get it. If you have a sprinkler system, likely, your house supply comes out to a manifold, comes out to some valves that can control individually each one of these pot, but it's gonna come into a manifold like this and then distribute from here to like your zones of your house. So generally, when you water your yard, you can't run it all at the same time. You kind of break it up into, you know, 6 or 10 sprinkler heads, depending on how much they flow and how much pressure you have to distribute water to a zone. So each one of those zones is fed from an individual pipe that comes off a manifold like this. And so in the machining world, in metal world, we might do a spot face to accept a coupler like this. So what you're seeing is kind of a little bit of machine work done. This would be on a rectangular part that I have. Um, I mean, in some ways, if we go back, so I just want to show a quick thing what a spot face might look like. It's this machine work to accept maybe a fitting of sorts and helps alignment. So if somebody spot faces something and this pipe's already spot face, I can almost like without measurements just come back and put my couplers on there real quick, weld them all out. Maybe this needs to be welded. Sometimes they're just bolted or threaded connections in piping systems. And sometimes they're plastic, sometimes they're metal, all different kinds of metal, all different kinds of plastic. So the world is big. The world is awesome. I mean, in some respects, I could tell you that that is a round feature now. I could tell you that's a piece of pipe because if I was looking down on a piece of pipe, it would look like a rectangle. If I'm looking at the front view of a piece of pipe, it looks like a rectangle. What I would need to just like I could totally tell you that this is actually a spot face on a round pipe and the through hole goes through both sides. What I would need to show somebody that is I would need a right side view or a left side view, but a right side view to show that it's round. And then I would clearly communicate to someone like, oh, I thought I was looking at a square block or something. Oh no, you're looking at a round pipe with totally. Yeah, like a cylinder. Yeah, if you think of just looking at a cylinder at top, a front and top, it looks like a rectangle. Yeah, exactly right. And so that's cool. Okay, we're continuing on. We've got a dovetail to do, and we've got a kerf, and we've got a Woodruff key and a T-slot. Okay, let's see. We can get these. I think I'm going to detail, like when I look at the dovetail, I'll probably come to the front view of this and probably draw this in front view, and then I can project up. So what we've got going on in the top view is we do see some visible line work. This is the surface where my eyeballs are in the top view. This surface right here is actually down in here. So this is the surface where my top view is taken, clear up here. That's why the depth of that dovetail down into this little point here, it shows up as a visible. It would be a visible line if I could see through it, but it's a hidden line. But it is like a feature of this component that if I had X-ray vision, I could see where the depth of that like dovetail kind of ends down in there. I don't get a depth perception at all from the top view. I get that from the front view, but anyway, yeah, yeah, that's good. One more thing I might add is that if I go back to my drawings here, when we're looking at top views and front views, I just want to explain the terminology we use for the uh, length versus height or whatever, right? I think we tend to drop the length term, even though I will tend to use it because I get mixed up all the time myself. But what we have in the front view is what we are looking at is height for sure, height. And then we are actually looking at width, which makes sense. I mean, this is height by width. When I'm looking at the top view, these are width by depth. So those are my three terms that I use is height, width, and depth. And we kind of dropped the term length. You may have some questions on like multiple choice questions where they might have a multiple choice selection where I saw one on this quiz that says, you know, it might say the width and depth in the top view are shared with what other view? And if I say, well, in the front view I have width and height, so they did the terminology for you know, for the I don't know, the the width times height, the terminology kind of changes from one view to the next. In my right side view, I have height and depth. In the front view, I have height and width. In the top view, I have depth and width. So I think you have a question that kind of is going to try to confuse the crap out of you on which view shares like features, kind of. Yeah. Anyway, side note, let's draw a dovetail. I've got my drawing up. Let me put it in. I think I'll start it from the front view. Tells me that it comes up, so I'll be on my visible line layer. Tells me that it comes over 10, so I'm just going to cursor over 10 millimeter. Then it goes down here to it's some angle here, right? It's kind of the problem I have here. It's 60 degrees, it says. That's kind of handy. This one is one that I can pull or snap to pretty easy. I have my 30, 60, 90 polar snaps on. And so I can come over here and say, well, if it's 60 degree, it's going to be like that. It's technically it calls it 120 on my cursor, but that is a 60 degree. I'm snapping to a 60 degree, which is what I need that to be, I believe. Yeah. That one's not as hard for me to figure out because it's a friendly like I say it's like a polar snap friendly degree. These other ones were not. These are not ones that I have like a quick snap tracking that I can use. But anytime I see like we can look down here. Anytime you see any of these in 5 degree increments, essentially, I can snap to them fairly good. There's 1836, 72. Some of these might have had what I needed, but it's all right. I left that long. What I could do is I could have had a construction line in here, and then I could have put that across at 8 millimeter here. Like I could have done this preemptively and said 8 millimeter down, draw across as a construction line. That's how far down that needed to go. So if, in the event that I hadn't drawn this yet and I had kind of planned on needing to know how deep it goes, I I could have cursored over 10 and then come down here and had my 30s, 60s on. There's 30, there's 60 right there, and then intersect there, have the intersection snap on. So in order for me to do that, I would have had to have that intersection snap right here. And I would have needed to have my polar tracking set to grab 30 degree increments. So I could be set there, I could be set on 15 and 30s, they would grab that. Uh, and I might come across and do the same thing, come over here and go over 10, and then do that 30, 60, intersect there. And then from there, I'm going to snap over like that. So the front view is almost done, other than doing a little bit of trim here, right there. Dovetail. And then I'm just going to project up. Since I've done all the work here, I'm going to use orthographic projection to snap this up to here. And I can take this all the way across if I want to. And the other one that's kind of on the top surface is this one that comes, I'll see that as a visible line in my top view because my eyes are perpendicular to that very top plane right there, that surface. This surface where it appears as a surface appears as a line right here. And that's where my eyeballs sit. So my eyeballs can't see this one right here. So I'm going to project it up and across. This one is going to become hidden line work because I just don't have the X-ray vision to see that, even though it's down in there 8 millimeters deep. And my eyeballs are not on that surface, so I can't see it. But if I use some hidden line work, I can communicate that a little more effectively towards someone else if I trace over it with my hidden line right there. And that one should be done, yeah? This one right here. 60, like I did use, I mean, I totally used this to drive my degrees there. So when I came over, what did I come over? 10. And then when I was on that point, I have those snaps on. I'll pull out a little bit. I have those snaps on so I can be like, here goes 30, here goes 60, 90, another like 30, 60, 90, and 30, 60. Yeah. It's kind of confusing. It's even confusing the way the dimension is put on there because it kind of shows where it is, but it's like not on the exact surface of it. You would think maybe the better dimension would be like show bring this like dimension down in here to be like 60 to show that's truly 60. And then typical, or you could say two places. So I'm going to clean this up a little. I'm going to make myself a better file with what we're drawing today. And then that I will replace that other one with, where I know that I've missed a dimension there potentially. And there's other places where I've missed some stuff. But what's the next one? Kerf. Sweet. A kerf is just like I think of a kerf as like when you cut wood with a chop saw, like a circular saw, even like a skill saw, like a handheld, just wood cutting saw, super dangerous, right? People get cut on them all the time. Yeah. Oh, okay. It's like, oh, okay. Oh, I'll stop casting. Yeah, it's all right. Stop my casting for a minute. But anyway, this cut, like a kerf is usually like everything that cuts something generally takes up some material to cut. Like a saw blade is a great one. It has a thickness to the blade. So when I cut into something, there's a groove left, or there's a groove that could come out of it. And so you have like kerf loss when things get cut through. Whether it's a laser, it has a kerf loss. So do water jets. So do like my little laser glow forge has like there is some thickness to the beam that it cuts. And and so sometimes I have to think about that. Um, I don't know why they have a straw curve. I don't, but it is. I think it's a good concept to understand that it's usually like usually it's a raw involved in this the stuff that is being subtracted out due to the thickness of whatever is doing the cutting. So when machinists mill stuff out, they kind of use like drill bits, but they cut it. They use them like they're made to cut on the side of the drill bit, where maybe the drill bits we're used to, we put it, the point starts to do all the cutting. And the flutes, the sides can't cut really. You can't like take a drill bit and like ram it in on the side and start cutting something, but machinists can. Machinists, they have mill and bits that will cut on the sides and they will actually create a kerf loss, right? They'll cut through something. So I feel like this is kind of like maybe a machining tool that's cut through. Of course, what I explain, if I don't have pictures, doesn't really make a lot of sense. But what happens is that um, I just need to know that it's a rectangle that's 10 by 4. That's all that really matters. And that it represents maybe something being cut through that, a tool that passed through that and cut. So let's draw that in though. I don't even know if I really need any. I'm going to draw it on the front view first. So I feel like I'm going to go over. It's from the center over, so maybe it's helpful to have a center line. I don't know how far it is over here, but this thing is like centered. So sometimes it's helpful to have a center mark. Maybe I'll put a construction center mark in like this. Yes. And then I just have something to reference when I draw. I could have just used the midpoint, but I'll show you. Like that is the midpoint. There was a midpoint that I could have selected in that top line, I think. But I come over, it's only 4 millimeters wide, so it's 2 from center over, and then it's 10 deep, and then it's 4, and then it's back up here like that. So I kind of built it from the center out. I cursored over 2 millimeter, went down 10, over 4, back up. Okay. So I'll throw myself on your screens again. Could it be that you have your ortho mode on? Yeah, you'll see me. I just don't use ortho mode a ton. There are times when I use it, but my biggest problem is that I have to remember to turn on F10 again, which is what I really usually like to have on the polar tracking. I just don't like that when I go to F8, it turns off that, but it won't ever turn it back on for me. It's like you can't have both on. You can either have ortho mode on or you can have polar tracking. And I prefer polar tracking. Trim this out though. Trim, trim. And let's let construction projection work for me here. That thing is going to come across and look like a groove or like a just a visible line. Same here. This is going to be on the top view. I'm going to be able to see those corners. I won't be able to tell the depth perception, but I did have to trim that out too because that visible line doesn't exist anymore. It is here though, right? Like don't think that that gets cut here because it technically um, this surface right here, while it's cut through, and I can see that it's visibly cut from the front view. From the top view, I should still see the side come through there because I'm still got a bunch of surface that's in alignment with this, where this surface appears as a line is right here. And even though it's cut through at the top, it still would the visible line would still exist here because that surface still is intact all through here. So this potentially this like very bottom edge here would still be a solid line. So you have to be careful on what to trim is visible and what's not. Woodruff key, sweet. We have a Woodruff key next. And really it's got this big a Woodruff key is for locking in uh, a motor to a shaft. It's a removable feature, but it is what trans it is what it is the key that locks together some rotation from some motor that can turn and then lock it into some piece of equipment that I've built to transfer the motor's ability to turn to something that I've designed that needs to turn. The key is what kind of holds them together. We would couple them together and key them together, and then I can transmit rotary power from something to something that I need to have turn. I think of like an auger that has to turn, like a screw in an auger. That thing has to turn, has to be hooked to a motor. Really, the relationship that is happening there is that motor has a little mini shaft that I can actually slip over something from my screw on my auger, and I can hook them together with a key. They're able to come apart. It's not like I weld them together forever. Like I need like a mechanical component that I can that wears out eventually and I need to replace from time to time. But this Woodruff key is a type of one. And it says it's a radius of 30. This works well because this one I think I can truly use fillet and input the distance as 30. So if I choose fillet and the radius and say 30, enter. It just so happens I think that I can say, is it from here to here will be, it might not let me do that. Maybe I would use a circle. I'm not sure how you guys did yours. I was going to do a fillet and just like let it cut it, but it will not do that exactly from two parallel lines. Um, I think a circle would be a good one to use here. So like a circle from this is center and pull it out to where it's, I'm drawing by diameter. So I have to think of like a 60 millimeter diameter. And then I could trim all this. And that one's done. That's a Woodruff key. Not all keys are Woodruff keys. Woodruff keys are kind of special. They have a lighter torque load than just a nice square key to fit into anyway. But we will talk about more about keys and key ways in the future and the details behind some of that. This is a T slot. Okay, it's kind of like the dovetail, but maybe a little bit easier. I'll draw it from the front view, from center out. The first T is 10 overall across, but if I'm drawing it from the center, I might cursor over just 5, and then I'm going to come down and say that this depth is 8. I'm just following the dimensions on my drawing. 8, and then it goes over another, well, 30, but I've already gone over 5. So you have to think about this as like, I've gone over 5. 30 is overall, so it's 15. So maybe 10 is what I've got to go over. That's just me doing some math while I look there. And then it's 8 deep. Then it is 30 across here. And I could have drawn this in as a mirror image too, like we've done on some other things, but I'm just going to draw it all as one. What I had to figure is that 10-inch long line and then back up to here. So essentially that ends up, I went over 5, drew down 8. I went over 10 because this total thing is 15 and I already had gone over 5. So I needed to go 5, 10 more over. And then back 30, up 8, over 10, up 8. I have my T slot. I just need to trim this out because it doesn't exist. It's really a locking type mechanism. We do this in plastics a lot. Kind of have maybe a T slot that then whatever needs to like slide. I feel like it's like a guide slot for something that's going to slide, like some linear motion sliding down this T slot of in a block. But and metal, we use there's a lot of configurations like this out of metal as well. So it's kind of like the dovetail though. This is going to be right where my eyeball sees on this upper surface of the top view. This one, enter, and then this is going to be hidden line work for sure. It's going to be the bottom of that. You know, this surface that appears as a line here is going to appear as a line here. I like the thought process of considering when surfaces appear as a line, right? Because that is a concept of orthographic projection. The front surface appears as a surface here. It appears as a line in the top view. Um, the little depth slot here appears as a line here, this surface of maybe how deep this is. It also appears as a line here. So in order to show the surface of like if I was looking like the way I'm pointing at that, I would need to show that in the right side view or the left side view. That's where these lines that represent a surface would appear as a surface in the right side view. If I truly took a right side view, they would appear as a surface that's hidden. If I took a cutting plane line and cut that in half and actually just drew, instead of drawing a right side view and having to show hidden line work, I can draw a right side view and actually expose and decide to cut through something and establish a cutting plane line. Then I can expose surfaces as visible lines. And sometimes I have to do that. So sometimes surfaces are buried, sometimes surfaces appear as lines, sometimes they appear as hidden surfaces that I may need to expose. And anyway, just a thought process I want to think through a little bit. This is done though. I just got to I've got to draw the visible lines here. Avon is calling, but I'm not going to answer. Man, is Avon even a thing anymore? Probably not. And then this one will be hidden. I did it as construction because I was wrong. So let me undo that and do my hidden line work here. Hidden is what I really want. I'm going to trace this over with hidden. And I think these are done. If you label them, extra points for you. If you don't, it's not. It's okay. There's no center lines on those. Kind of interesting. Remember, center lines really are associated with round features. It could be argued that maybe this would have a center mark on it, but I didn't put it on it, so I'm not going to hold you accountable. I mean, technically, we don't usually put center marks on just a standalone round or a fillet, but sometimes we do. So, but generally not. I think these would be fine left, and even on this inside fillet. So all I need to do is check my paper here. This one, half size. I already kind of aligned mine, but I'll turn off my construction work here. And then I've just got to probably go through and just take a hard look at my line type scales probably. I'll bring this in a little bit here. Yeah, go ahead. Probably.
Nope.
Yeah, it is. Missing my visible lines, right? Maybe I drew them on my construction layer or something. Yeah, I should have that hard line there. I don't think I traced over. Let's go back. Good catch. I think I probably drew the projection lines, but I never traced over them. You're right. Yes, let me and hopefully I would have caught that if I started to really analyze my PDF, but this one should be a visible line that I should have. Now let me go back. I'll turn off my layer here again. Construction layer off. Back to here. Yeah, I've got it locked in already at 1/2 scale. I was just adjusting my viewport a little bit within the boundary. Not that it matters, it wouldn't be on there. I've already turned off my grid, right? If you're in there and that grid's kind of driving you crazy, you can just turn it off. I just want to adjust the line type scales. They're pretty fine here. Metric will always kind of be this way, so maybe I'll take this out to at least 5. Is that what we've kind of liked? 5 looks good. Then I might just match those properties. So I think I can take that and just match my other. Well, that's a little too coarse for those two. So I think I'll back up. I'll leave that other one as 5. I might have to drop this to like 3. It's just a smaller circle, so the center mark didn't quite break up. That one's bigger. I could match that one to this one, I think. Yeah, that looks good. And then I'll just pick a line. I think I'll try the same thing with this one. Maybe it's a 5 on, that'll work good. So I think I can copy this one for all my vertical center lines. I'll match properties on this one, match properties, and then select these other ones that I want to have match. That one, that one, that one. This one here. And then I just have one more, maybe of the smaller circle line types. So my nature of line type scales are generally I like pick one and like it or not. Like I'm going to go over here and I didn't join any of these two. I could have joined some stuff, but it's okay. Join, maybe I'll do a 5 on these as well. You could argue that I could make that a little coarser, but I think I'll leave it as a 5. Sure. I'll match these properties. That one, you can pretty much go around to all of my hidden lines. This has a fair amount. I could do a quick search for my hidden lines. There is a search up here in my properties tab to do like a quick select search. Maybe I need to explore that maybe next week and have everybody. Maybe I won't talk about it today, but there are faster ways to maybe to select your line types that you're looking for, and I could maybe I could search for all hidden lines and then apply the line type scale from one. So I'll show you that next week. I'll put it on my to-do list to because on a really busy drawing, this might be really annoying. You have to go through and like click all these, but I think I did get it. This is okay. So this is done. It just needs to be called what it is, which I think I don't know what I called this assignment. Let me look at my
You call it chapter 4 theory tooling.
tooling drawings. Yeah, that's weird. What a weird name, but that's good. That's actually what it is, and that's fine. I will. Chapter 4 from the theory book. Yeah, theory tooling drawings. Because I think of it as like stuff that's being like cut, and I got to just realign that a little bit to my center justified. And I might not be able to have that on the upper. Do I have that the right? Let me check I am on the 3 mm. So yours might not have fit. I bet you I don't have the right on the assignment that's posted. I bet you I don't have the right size of text if it actually fit in there. Or actually, I think I do. I think what I did is I eliminated the upper line probably like that. Maybe I bet you I did some little fix like this to drop it down strategically because something like that. And then my date, 17th, 18th. I think Jimi Hendrix died today, but well, back in 1970. So long before any of us. And then I saved this thing. Yeah, I've done all this work and never hit one save. That's a little dangerous. I do want it saved as a drawing. I want it saved in my theory class in week 3 or 4. It's actually from week 3 is probably where it shows up for me. So I might actually, when I actually really name this file, I might name it what the chapter 4 theory AutoCAD. I'll name it something that I can recognize. I'll probably come back and do a little modification to my naming, but I just wanted something, some uniform. I'm trying to come up with a uniform naming system eventually, and I might even start implementing like drawing names, but I think that's it. Yeah, I'll take like a 5 minute break and I'll stop. I'm gonna stop this. I did record this.